Well, here we are back in the science cave, and we're looking at Newton's third law. And Newton's third law, for every action, there is an equal and opposite, reaction. And it's right over here. Well, we notice that this all the time, and this is why things move and why they don't move. Here's our example of an engine here, and we'll be doing this with our rocket launches. The exhaust flow pushed backwards, so therefore the engine is pushed forward, and that's why a rocket will fly. Quite often what you're going to find, if they are equal and balanced in opposite directions, you're not going to get any movement at all. Let's say we got an object sitting on the floor, and this object is pushing down with a certain amount of force, and the floor is pushing up with the same amount of force, and it's equal and opposite, you're not going to get any movement at all. What we have over here with the oar is pushing on the water, and the water is pushing on the oar. And so what we have here, we have for every action there's an equal and opposite reaction, but they're not in exactly the same or opposite direction of each other. And the curve of the blade, the angle at which the blade hits the water allows in the paddle to propel as it strikes the water to propel the boat, or in this case the paddleboard, forward. This is where a lot of people get kind of messed up on this equal and opposite. Quite often when you have motion, you don't have exactly opposite forces acting on things. If you look when you stand, and we'll look at this. If we're standing, let's see, we're standing on a floor, and we're here. If we're just standing still with our foot is pushing down in this direction, but the floor again is pushing up at an equal and opposite reaction. So an equal and opposite force. So there's no movement. The thing is, when we run or we walk, and we'll demonstrate this in class because I'm definitely not going to be able to draw this very well. We have our knee lift. We no longer, the floor is pushing up in its direction, but now our forces are pushing at a force that is not directly opposite. So now we have what's called an unbalanced force, and when you have an unbalanced force, quite often you're going to get motion. So you have an unbalanced force, you're going to get motion. When forces are completely the same magnitude, if forces have same magnitude, or size if you will, magnitude and opposite direction, what you end up having, you have no motion. And this holds true for most, for most instances that you're going to run into. Typically what you end up having, you have an unbalanced force, or you have the force is not in an opposite direction, and therefore you're going to have some motion on there. One thing, if you notice, if you don't think anything's pushing back at you, if you have your hand, and I'm not going to draw a very good hand here, but if you push down on a desk, the desk is pushing back on you, your hand is actually flattening out, and you can feel that. And if you don't think when you're running there's a force put on you, try running in your bare feet on the floor, and you can definitely feel the force. And that's or let the force be with you, as the case may be. But that's why shoes quite often are there to add some cushioning with that. You know, these 3 Newton videos, you can watch the Con videos. There's tons of stuff out there on the internet on these. And I'm just kind of give you just a general overview of these. So this will be the 3rd one, and we'll continue from here. So hope you enjoy these.